Hi everyone. This question here says, determine whether each relation is linear or nonlinear and explain your decision. Okay, let's zoom in a little bit here. Let's take a look at this first one. Okay, notice that we've just got a set of 4 points here. Now it's not a straight line in that it's connected here, but is this linear? Well, the answer is yes. Okay, this is linear. And the reason I can say that it's linear here is because notice we've got a constant rate of change. Okay, when I move horizontally 1 over, I move 2 up to get to the next point. 1 over, 2 up, 1 over, 2 up. So that's a constant rate of change. And as such, that makes that linear. Over here, is this one linear? And the answer is this is nonlinear. Okay, and the reason for that is because this is degree 2. Or because it is second degree. Okay, it's quadratic, if you will. Because the r is the variable here. Now pi is not a variable. Okay, remember pi is a constant. R is the variable here. And because it's squared. Okay, now think of it like this. We know what this formula is. It's area of a circle. Area is equal to pi r squared. Area depends on radius. Okay, so this is our independent variable. And because the independent variable is being squared, this is quadratic. It's not linear. Okay, let's take a look at the next one. C. Now let's just take a quick look here. And essentially I got to figure out what the slope is. Now it might help just to figure out what the slope or the rate of change is for a couple of these. So let's just take a quick look. We'll use M. Let's maybe just take a look at the first two points here. So 3 minus 5 over 1 minus negative 2. So 3 minus 5 is going to be negative 2. 1 minus negative 2 will be 3. So between those two right there, there's a slope of, or a rate of change of negative 2/3. Let's pick another one. Okay, let's maybe pick, I don't know, let's maybe pick the last one here. So negative 3 minus 1 all over 10 minus 4. Okay, negative 3 minus 1 will be negative 4. 10 minus 4 is going to be 6. Okay, and that's going to give us negative 2/3. Okay, well that's looking pretty good here. Let's just take a look at this middle pairing here. Just again for one more check here. 1 minus 3 over 4 minus 1. And again, 1 minus 3 is negative 2. 4 minus 1 is 3. So yeah, every time I took a pair of points here, I got this rate of change of negative 2/3. So is it linear? Yes, it's linear. Whoops, sorry. Yes, it's linear. And the reason for that is because it's got a constant slope. Okay, now that's going to kind of, sorry, I kind of moved into that other question there, but that's okay. Take a look at D. And yes, this is linear. And again, we can go back to an earlier definition here. This is linear because it's degree 1. Okay, this is just a first degree equation here. That makes that linear by default. Let's look over here. Is this linear or nonlinear? Well, let's just take a look at the rate of change here. And actually, I think this is pretty clear, and I don't have to even look at too many points here. Notice that my x variable here, my independent variable, is just going up by 1 with every step. But here, initially, the dependent variable doesn't even change. And then it goes up by 1, and then it increases again by another 1, and then it increases by 2 here. Okay, so the way that the y coordinate is changing is not consistent or proportional to the change in the x, so this is nonlinear. Okay, and again, we might even say our rate of change here. Let's pick the first two here. That would be 1 minus 1 over 2 minus 1, so 0. Okay, and then if we picked a different pair of points here, let's maybe pick the last two here. That's going to be 5 minus 3 over 5 minus 4, and that will be 2 over 1 or 2. And so the rate of change isn't constant there. Now, here's another question here, another set of points. Okay, very similar to one of the previous ones here. Now take a quick look here, -5, -2, 1, okay. it's probably not clear just by looking at it whether it's linear or not. So let's take a look at the rate of change. Again, we use m for that. Let's take those two right there. So 1 minus 0 over negative 2 minus negative 5. Okay, well 1 minus 0, I think that's pretty clear. That's just 1. Negative 2 minus negative 5. Please be really careful with the negatives there. That's going to be 3. Okay, let's maybe compare those two. The next set of points there. So 2 minus 1 over 1 minus negative 2. Okay, 2 minus 1 is 1. 1 minus negative 2 is going to be 3. Okay, well that's looking pretty good. So between these, I've got a constant slope, but you know what? That doesn't mean that the rest of them are going to be that way. So let's take a look at that next pair of points. Okay, I've got 3 minus 2 over 4 minus 1. 3 minus 2 is going to be 1. 4 minus 1 is 3. That's still looking good. And this last pair right here, 4 minus 3 over 7 minus 4. 4 minus 3 is 1. 7 minus 4 is 3. So yeah, every little pair of points that I grabbed out of there, and they were all connected, right? So I used this one twice, this one twice, this one twice, all along there, chained them all along. The rate of change is the same, so this is linear. Now, down here, take a quick look at this last question here, and I mean you should be able to tell by looking at it, this is not linear. Okay, this has got this curved shape to it. Notice that the rate of change, if you want to think of it this way, is not the same. Because if I go horizontally over, what is that, 1, it looks like I'm dropping 5 here. Go over another one, and I'm dropping 15, and another one, I'm just dropping by that much more here. So this is non-linear. Okay, there is no constant rate of change. Okay, that varies as we go along here. So not linear.